Hello and welcome, dear students, uh, to the week 2 of your online classes. This is the lecture 2 for your week 2 for MS 495, that is Green Supply Chain Management, being offered by GIKI Institute for the semester Spring 2020. Alright, I'll continue with the previous lecture. Uh, we discussed that the only learning outcome for these lectures is basically you'll have an understanding of exactly how to perform the calculations for life cycle assessment. So moving further with our discussion, we stopped at inventory analysis. Moving ahead, the next part is life cycle impact assessment. That is the most important part. We discussed earlier that we'll be using standards like CD. We might use impact 2001 plus. Uh, we might use global standard or whatever standards it is. And we also said that we are going to measure exactly the energy requirements. We will be measuring CO2 emissions. We will be measuring global warming potentials. So exactly coming onto this stage for life cycle impact assessment, we have already defined our standard. We also know the indicators relevant to the standard. The next step is that exactly in my previous slides, if you can remember, that we formed that the first stage is raw material. That was basically acquisition, transportation, followed by manufacturing, uh, that had obviously, we'll say, transportation to the warehouse as well. And then we were concerned about exactly disposal, and that also for two categories. One was recycling and other was landfill. So R is for recycling, this is for landfill. So we made an inventory analysis table as well, where we discussed that exactly what amount or what units of inventory are required for the process. So if you can see that the first two processes or the first two stages are same for our study. The only difference, or what we really want to compare, is at the disposal stage. So we may say that we use the first two as constants. As constants, I mean that I told you in raw material acquisition, we say that for polypropylene, and we were using a unit of 100 tons of diaper used around the year, we say that uh, for this much, 20 tons of polypropylene is used per year. So exactly what we are really now interested to calculate, how much energy is required to transform this polyethylene or to acquire this polyethylene. This is something that is a plastic, is processed after some processes, and going through literature review that needs to be extensive or going through some other detailed studies, we find out that supposedly polypropylene is roughly, let's say, consuming 30 gigajoules of energy per year to manufacture this much amount. Similarly, we'll go for polyethylene. We are simply now in the raw material stage. Polyethylene, we say that we use 30 tons of polyethylene per year, and roughly we say that this consumes around 60 gigajoules of energy. Also, we can say that with this process, that might be process A, process B, whatever it is, this 30 gigajoules of energy, obviously this can be from diesel source, this can be from coal, whatever the source you are using, you really need to be sure exactly what are the things that you're looking at. There is a lot much literature over the internet available for exactly calculating the energy requirements and the CO2 emissions. We might also say that this 30 gigajoules of energy consumption also emits roughly around, we say that, okay, let's make it 10 thousands or kilotons of carbon dioxide. Similarly, you can say this polyethylene as well. This process is contributing to 30 tons or of carbon dioxide or carbon dioxide equivalent. It depends on whatever sort of data values we do have available with us. So for this bit, we have discussed the energy requirement, we have discussed the CO2 emissions, and we also need to really calculate the global warming potential, that because of polypropylene, we might be emitting, in some process, there is a potential that we might be emitting methane gas, we might be emitting some other gases that have global warming potentials. And using the literature, we can use the values for global warming potentials as well across with these materials. So exactly, we can come across that all our three indicators are fulfilled. We calculate the global warming potential, we calculate the energy requirement, finally we calculate the CO2 emissions or the greenhouse gas emissions, similarly for this as well. And similarly, we need to do for cellulose as well. That was our material. So for all these materials, we come across certain level of values that exactly form these materials. So we might say that at the raw material acquisition stage, 30 gigajoules and 60, 90, supposedly this is like 70 gigajoules. That is like 160 gigajoules of energy is consumed at the raw materials acquisition stage. Similarly, you can say that roughly around 60 tons of CO2 emission is also emitted. We can go for global warming potential as well. On a scale, we can say that this has a global warming potential of roughly around, we can say, 50. And we use the units as well. So this is our first bit, that we complete the life cycle calculations for our raw materials. The next stage was your manufacturing. So for manufacturing as well, we can say that we simply take all the processes, that is process A, followed by process B, followed by process C. This is something that you can easily perform in your unit modeling calculations or data modeling calculations. So once we have an idea exactly which processes are there, what is the energy input, what is the output that is being generated, what sort of emissions are being emitted, so we get realistic value to exactly how much amount is manufacturing contributing towards making 100 tons of diapers a year. So basically we might say that it's consuming somewhere around, let's make it 120 gigajoules, 400 tons per year. Now we have scaled this to one diaper as well. So if 100,000 tons is being used per year, we can calculate the weight for a single diaper, that is roughly around 36 grams. And we can say that this much number of units of diaper is being formed. And then we can easily calculate that exactly for one unit, how much amount of energy is being contributed. So in the first two stages, we come to know that exactly 160 plus 120, that is like 280 gigajoules of energy is being consumed in the first two stages. Similarly, we can go for CO2 emissions as well, or whatever indicators we have been using for the study. So let's move ahead to exactly calculate how we'll go for this disposal stage. Okay, dear students, we have moved on to our next bit. That is basically for life cycle impact assessment. That is more concerned about the recycling or the disposal phase. So we say we have two things to compare across. One is recycling, one is landfill. So in our previous stage for inventory analysis, we could have made unit processes for these things. That recycling is like shredding, followed by putting it in a centrifuge, followed by some other process C. Similarly, landfill, simply transport it and take it all the way to the landfill. The landfill site is processed. We can say that it's a controlled landfill environment. And finally, we just simply dump them. So both these processes have various sort of energy requirements. We can say that obviously this is transportation. I may say that in transportation, if I'm going for a truck or shipment transportation as well, I really have the amount traveled, and for truckloads, we can use ton kilometers to exactly how much kilometer of distance is traveled, because the more the load you put up, the less the fuel efficiency you get. So these are some of the factors that are readily available over the internet. All you need to do is to sit down and give a detailed analysis to that. So I might say that supposedly this much ton kilometer, I get a fuel efficiency roughly. I say that, okay, my truck is going for 2.5 kilometers per liter, and I have a distance of 1,000 kilometers that is traveled during the transportation stage. So exactly, it's giving 2.5 in for every 1 kilometer. So for 1,000 kilometers, this is like 1,000 by 2.5. So this should be somewhere around, like, I hope 400 or whatever. So this is the amount of diesel in liters that's being consumed. So we can calculate that 400 liters of diesels can emit, or their net calorific value, that is basically exactly like if 1 liter of diesel is burned, it might emit, or it might use 13 kilojoules of energy per liter. So we can simply multiply this with this thing to exactly calculate how many kilojoules or gigajoules of energy is transmitted or consumed while transporting. Similarly, if we get to know the fuel efficiency, like that's 2.5 kilometer a liter, we can say that for this particular truck or this particular diesel that is being used, the CO2 emissions is 20 kilogram of CO2 per kilometer. That's obviously too much. Whatever it is, we use the relevant factors to get an idea to exactly what amount of things are being emitted. So for the truck emissions or transport emissions, global warming potential can be significant in a few cases, and it cannot be significant in a few cases. So if something is that is really insignificant and that data values are not readily available, you really need to, you can simply skip that or omit that bit or part. Moving ahead, people, the next, obviously for landfill, we calculate the similar things, that we say 1,000 gigajoules is consumed during all this processing. We say that 100 tons of CO2 is emitted for all this thing, that is like processing 100 tons of diaper a year. Similarly, we can say that global warming potential as well, somewhere 60, 70, whatever it is. So we exactly know the values for these two realistic scenarios. And what happens for all our life cycle stages, we simply accumulate all those values. That was raw material acquisition, then we had manufacturing, and then we had disposal. So we calculate for recycling, and similarly, we calculate the same for landfill. So finally, at end of the day, we might be having certain values that recycling is consuming roughly. We can say, okay, 500 gigajoules of energy and emitting somewhere around, or we are saving as well. We can say that we might save, because if we extract polypropylene, polyethylene, we can say that we are saving CO2 as well. So that is something that we simply just subtract from our gross requirements to calculate the net CO2 that is present. So we might say it's emitting roughly 100 kilos of CO2. Similarly, we can say something for the global potential. Here we might say that landfill consumes less amount of energy, but it is more contributing towards CO2. So basically, that's exactly how we would do our comparison in a life cycle assessment study. For these two things, the next part obviously is your interpretation. So for the interpretation, let's just pick up these values. I say that recycling consumes 500 gigajoules of energy and emits 1,100 kilos of CO2. So I can say that in terms of CO2 emissions, recycling is a much better process, but in terms of energy requirement, that is a more extensive process, though it is not. This is just for the sake of an example. Similarly, I might say that landfill consumes 200 gigajoules and kilotons of CO2 emissions. So I can say that is a less environmental friendly process as compared to recycling. So this is basically what you really need to interpret, that in terms of your endpoint indicators, that was basically your environment. So with this discussion, that exactly what interpretation tells you, that is more of qualitative analysis to whatever you have done in terms of your calculations. Obviously, once we have not much number of indicators, the interpretation really becomes complex. But for the sake of assignment, I really need you guys to pick up at least 4 indicators. That is more of a relevant or more realistic level of difficulty that is for you guys. So people, with this, we come to an end for our week 2 lecture 2. Hopefully for now you are able to have an understanding to exactly how you may perform calculations for a life cycle assessment. Obviously all your queries will be dealt in the next interactive session. So thanks a lot for listening. Happy learning.